Hello, my name is Keith, and I'll be your instructor today. Just by a quick show of hands, who here feels like they've got a pretty good sense of direction? Okay. As an exercise then, everybody point north. Now, that might be a little bit of a softball for us. We've all lived in this area for a little while, so we've got a pretty good idea on our cardinal directions. But let's just say we're going to a new place. Say we're going to a new dive site. Would you be as confident in your answer and being able to point north?
No.
No, most people wouldn't. Okay, it takes a little bit for them to get familiar with that particular area. Now, to aid us in that, we've got a couple of tools at our disposal. Some people pull out a cell phone and they'll take a look at a map and be able to determine north from there. But a lot of us, most of us, especially when we're operating underwater, won't have our cell phones with us. In fact, cell phones won't work underwater. But something that does is our compass. Okay? It's been used for hundreds of years, and it is a tried and true navigational tool for us to be able to conduct any of our dive operations and dive exercises as we're going underwater. The value for this is to be able to safely navigate your dive and be able to exit the water at the point of entry. Whether that be a boat or from shore, getting back to where you started and safely making your exit is critically important to us being able to continue to dive in a given area. By the end of this lesson, you will be able to plan out and navigate an equilateral square, so that way you are entering your water at a certain point and you're exiting right at that same spot. And we're going to be accomplishing this via three main objectives. These key points are a review of our compass and being able to take headings appropriately, being able to calculate and apply what are called kick cycles, so that way we can track our distance. And then third, being able to go through an exercise where we plan out an equilateral square. Do we have any questions on what the objectives of this particular lesson is?
No.
All right. So we'll move into the first key point, okay? And that is our compass, okay? And all of you have a compass out there in front of you. And if you turn to page 34 in your dive books, you'll have a couple of pictures of different compasses. The compass that we're going to be using is the direct card compass, okay? And that is what you have in front of you right there. A quick overview of the parts and components of our compass. We have on the outside of our face a rotating bezel that has a double index notch and a single index notch, as well as degree markings around the exterior of the bezel itself. Okay. Down the center of our lens is a non-moving lubber's line. That is going to indicate your direction of travel as we navigate through the water. Oftentimes, your compasses will also have a viewing window on the side with another lubber's line, and this will allow you to take some readings as you are fixing your position in the water or trying to get a bearing on a point of interest as you go throughout your dive. Okay. And then lastly, probably most important, is your rotating card in the compass itself. As you can see on there, we've got a north-seeking arrow that is depicted, as well as degree markings on a lot of our cards as well. But that north-seeking arrow is probably the most important part of the card, okay? That north-seeking arrow needs to be aligned with your dual index notch for you to be able to take that accurate heading. Does that make sense? Do we have any questions on that so far?
No.
All right. Now, important parts for using this particular compass, okay? That card is floating. It's carefully balanced in a fluid-filled capsule in the compass itself. So it's important that when we are actually rotating the compass, we have it nice and level, so that way the card does not bind up and send you off on an incorrect course. I've seen it happen. I have been that diver before, but it's important that you just kind of keep that in mind as we are performing these steps and actually navigating throughout the water. Okay? Now that we know what our compass is capable of and what it does to function appropriately, we're going to go over how to actually take a heading. Okay? To take a heading, you will actually identify which direction you want to go. Let's just say, for the sake of example, 60 degrees. We will take our fingers, we will rotate our bezel until 60 degrees is right above our lubber line. We will then level out our compass, and then we'll rotate ourselves until that north-seeking arrow is aligned with that double index notch. Okay? We like to refer to this as putting the dog in the doghouse. That double notch being the doghouse and the north-seeking arrow being the dog. Okay? Dog's got to go home. We put him in the doghouse, and that's going to allow you to actually move in that 60-degree direction, or whatever degree that you decide to set on the bezel. Does that make sense? Mm-hmm. All right, quick exercise. Everybody shoot me a heading of 330 degrees, and then rotate yourself in that direction. Again, remember, rotate the bezel, and then put the dog in the doghouse. All of you should be pointing right at me. Perfect. All right. Do we have any questions on how to take a heading? Excellent. The next key topic that we'll be going over are kick cycles. Now, how do we measure distance in the water? Most of us don't take a tape measure with us. And if we were on land, a lot of us would measure distance by the number of paces that we would take, a pace count, if you will. Underwater, we use what's called a kick cycle instead. And it's every time I have kicked with each leg, it would count as a kick cycle. And 1, and 2, and 3. And this is how we establish how far we are going. Now, before we actually go and use that as a unit of measurement for ourselves, we have to be able to test that out in a controlled environment. Something like a pool where I've got a set distance and I can actually count my kick cycles so I know how long it takes me to be able to move 100 feet or 100 meters or 50 meters. Whatever that is, you need to go and make sure that you have tracked that out before using this in underwater navigation out there in the ocean. And with that, you need to understand that your kick cycles are going to be different than everybody else's. Gary, would your kick cycles be the same count for 100 meters as mine would be?
No.
How about you?
No.
No. It's going to be individual for everybody. And it's important that we make sure that we have tracked that and we validate that in a controlled environment. So, now that we have gone over our compass, we have gone over taking a heading, we have gone over kick cycles and what that actually means for ourselves, now we start moving into actually planning out that equilateral square. So first off, I think everybody's taken geometry or at least understands basic shapes in the class. Okay, we all know what a square is, but what's an equilateral square in particular?
Or with 4 equal sides.
It's got 4 equal length sides. Okay, and what angles go in the corner of this square? 90 degrees, that's right. Okay. And there we have it, an equilateral square. If I were to take a point, say right here, and I were to draw this square in one continuous line, where would I end up? I'd end up right back in my starting point. And that's the purpose of this. That's the purpose of us going through the equilateral squares to end right where we started. Now, let's just say we were going to trace this equilateral square in the ocean. And I would like you to start off at, say, a 30-degree heading. So we're going to move in the direction of 30 degrees. and we're going to go 10 kick cycles. Okay? I have rotated my bezel. I've struck my heading. I've rotated my body, so my direction of travel is appropriate. And now I've gone through my 10 kick cycles. And I've completed my 10 kick cycles. If I'm trying to make a right turn, what would I have to do? Should I add 90 degrees or subtract 90 degrees?
Add.
Add 90 degrees. So, what should our new heading be right here? 30 plus 90?
120.
120. And how many kick cycles should we do for that side?
10.
10. Completed my 10 kick cycles. I'm coming up to another turn. Want to turn right again. What am I doing? Adding 90 degrees?
Yep.
That's right. Okay, so what would our new heading be?
210.
And how many kick cycles?
10.
Another 10. All right, we've come to our last turn. It's a final right turn.
300.
300 even. And 10 kick cycles. Again, we rotate our bezel, we rotate our body, nice and level, and we conduct our 10 kick cycles. And in doing so, we have gotten ourselves right back to the start. Do we have any questions on the mechanics for our equilateral square?
No.
Excellent. Now, a lot of this is good. The math is not especially difficult to do, but I will say, being able to draw out the diagram, being able to have the math already done before entering the water in the first place is much, much easier. So it's always useful to have a dive slate or wet notes to be able to plan these things out for your dive, so that way you remember them, you're able to keep track of them, and be able to provide effective communication to the rest of your dive group, and your dive buddy especially, as to what you are going to be accomplishing. Okay? Dive slates, wet notes, incredibly useful. We do have them for sale over here in our shop. I encourage you to examine taking a look at picking one of these up to be able to provide yourself some additional planning. Additionally, these types of items, both the dive slate and the planning, as well as your equilateral squares, are going to be very useful for you as you continue on in your dive education. Pursuing rescue diver, for example, where you are going to be expected to execute some advanced navigation, for search patterns, for being able to navigate to lost equipment, any salvage efforts, anything like that. That would be an incredibly useful application for the equilateral square. Okay. So, in review, we have relayed the information to be able to conduct and navigate an equilateral square. And we've done this by orienting ourselves to our compass and how to take a heading, by going over kick cycles and how to use that in navigation, and then by conducting the actual planning of an equilateral square for execution. At this point in time, do we have any questions?
No.
All right. As a quick dry run, practical application, if you will, I would like you all to conduct the planning for an equilateral square. Okay? I'd like our initial heading to be 120 degrees. And instead of right turns, I'm going to toss a curveball. We're going to take some left turns instead. Okay, so again, you'd be adding or subtracting the 90 degrees.
Subtracting.
You'd be subtracting the 90 degrees. I'll be cycling around the room to check on your progress and see how you're going with this. If you have any questions, by all means, throw a hand in the air. I'd be happy to answer them for you. All right, let's go over our answers real quick. Okay, started off at 120. What is our next heading?
30.
30 degrees. I subtract 90 from that. We go around the circle.
No.
We get to 300 degrees. And then subtracting 90 degrees from that, we've got 210. And then to validate our math, if I subtract 90 from 210, what do I get?
120.
120, right back where we started. Excellent work. Do we have any questions on how that math kind of worked out? All right, excellent. We're going to practice this in the pool, so stand on up. Let's head over to the pool.